All right, let's dive in. Today, we're going to pull back the curtain and take a look at the magic happening inside your computer every single second. It's a journey into the digital world, so let's get right to it. I mean, really think about it. You click your mouse, right? You probably do it thousands of times a day without a second thought. But that one tiny action, it kicks off this unbelievable chain reaction. It feels instantaneous, but what's really going on is this lightning-fast conversation inside your machine. And that's what we're going to do today. We're going to follow that conversation from the click all the way to what you see on the screen.
Okay, so first things first, we got to start with the absolute basics. What is a computer really for? At its core, its job is to take a bunch of, well, meaningless noise and turn it into something that actually makes sense to us.
Yeah, that's pretty much it. A computer is basically a transformation machine. It's not thinking in the way we do. Nope. It's just an incredibly fast and obedient instruction follower. It takes raw, jumbled up facts, that's what we call data, and by following a set of rules, it spits out something we can actually understand and use. And that, my friends, is information.
And this whole transformation process, it happens in this constant four-step dance. It's a loop. First, there's input. That's you clicking the mouse or typing on the keyboard. Then, the computer processes it. It figures out, okay, what do they want me to do with this? Next comes the output. That's the window opening up or a character appearing on screen. And finally, it stores the results, like when you save a file. Input, process, output, store. Every single thing you do on a computer, big or small, follows that exact cycle.
And this difference between data and information is so important. Seriously. Think of it this way. The number 101 on its own, it's just data. It could mean anything. But when you add context, like 101 degrees Fahrenheit, suddenly it's information. You know it's hot outside. This is where that old saying garbage in, garbage out comes from. If you feed the computer junk data, you're going to get junk information back. It can only work with what you give it. All right, so now we know what a computer does. It turns data into information. The big question is, how does it do it? Well, it's time to pop the hood and take a look inside the digital brain. So the brain of the computer is called the CPU, or Central Processing Unit, and you can basically think of it as having two main departments. First, you've got the control unit. This thing is like a frantic traffic cop standing in the middle of a busy intersection, just directing all the data where it needs to go. Then you have the arithmetic logic unit, or ALU. This is the math whiz. It's a ridiculously fast calculator that handles all the numbers and all the logical decisions, like, is this bigger than that? These two work together to get literally everything done. And hey, just like our own brains, computers have two different types of memory. First up is RAM. Think of RAM as your short-term memory. It's where you hold your current thoughts, what you're working on right now. It's super fast, but it's also volatile, meaning if the power goes out, poof, everything in it is gone. Then you've got your hard drive or your SSD. That's the long-term memory. It's a bit slower to access, but it's permanent. It's where you store your memories, your photos, your files, all the stuff you want to remember later. Okay, so we've got the brain, we've got the memory, all this physical hardware. But you know what? On its own, it's just a really expensive paperweight, a hunk of metal and silicon. It needs something to bring it to life, to tell it what to do. And that's the software. It's the ghost in the machine. It's this perfect, essential partnership. Hardware is the body, the physical stuff you can actually touch, like your screen, your keyboard, the CPU. Software is the soul, the mind. It's the set of instructions that tells the body what to do. You absolutely cannot have one without the other. They're useless on their own. What good is a web browser without a screen to show it on? And what good is a screen without any software to tell it what to show? And all that software kind of falls into two big buckets. First, you have system software. Think of this like the foundation and the operating system of a house. The plumbing, the electricity. This is your Windows, your Mac OS. It's the stuff that manages all the hardware and just makes the computer work. Then, on top of that, you have your application software. These are the tools and furniture in the house, the stuff you actually use to get things done, your web browser, your games, your music player.
So there you have it, hardware and software working together to make one computer do its thing. But how did we get from giant room-filling machines to the sleek devices in our pockets? To figure that out, we need to jump in a time machine for a quick look at how these things have evolved.
And wow, what a ride it's been. The pace of change is just insane. In the beginning, first-gen computers were these enormous beasts running on fragile vacuum tubes. Then came the second gen with transistors, a huge leap that made them way smaller and more reliable. The third gen gave us integrated circuits, packing tons of transistors onto a tiny chip. And then, the game changer, the fourth generation's microprocessor. That put the entire brain, the whole CPU, onto a single piece of silicon. That's what gave us the personal computer. With every single generation, they got smaller, faster, cheaper, and way more powerful. And that brings us pretty much to today, to the fifth generation. But the story isn't just about what's inside a single computer anymore, not even close. The real story now is how billions of these machines are all connected together, all across the planet. And that's really all the internet is when you boil it down. It's not some magical, mysterious cloud floating in the sky. It's a real, physical network of computers connected by wires and wireless signals. It's just a gigantic system for sharing information. And it works because all these computers agree to speak the same language, a set of rules we call protocols. That's what lets your phone in one country talk to a server in another. So let's bring it back to that click. Let's say you type a website address into your browser. You're actually starting another little journey. See, your computer has no idea what example.com means. It's just a name. So it has to ask for help. It contacts something called a DNS server, which is basically the internet's phone book. It asks, hey, what's the number for example.com? The DNS server looks it up and gives back the site's real address, a string of numbers called an IP address. Then your browser dials that number, asks for the web page, and the server on the other end sends it all back to you. And this all happens in the blink of an eye. It's incredible.
So, we've gone from a simple click all the way through the digital brain, the hardware, the software, and out into this massive connected global network. We're living in that fifth generation right now, a world defined by AI and constant connection. Which leads to the ultimate question, right? What's next? What does this sixth generation even look like as these devices get smarter, smaller, and even more woven into the fabric of our lives? Now that is something to think about.